My voice may sound a little weird tonight. I just got back from the dentist and my mouth is half numb, so we'll see how this goes. The distributive property is a very important rule in algebra. You will be using it all the time, and there's a ton of different uses for it, so this video might be a little long. We'll see how it goes. The rule is stated as this: for all real numbers a, b, and c, a times b plus c will equal a times b plus a times c. And the same is true for subtraction. So if there's subtraction inside these parentheses, a times b minus c equals ab minus ac. So here's some examples of that. Notice a, b, and c can be any real numbers or any numbers. So a could be 3, for instance. So we could have 3 times 5 plus 2 will equal 3 times 5 plus 3 times 2. And that's pretty obvious here. We can say 7 times 3 would be 21, and this would be 15 plus 6, which is 21. So we know that this is true. And let's do an example of the subtraction version. So let's say a is 4, b is 5, and c can be 3 this time. So 4 times 5 minus 3 would be the same as 4 times 5 minus 4 times 3. So 5 minus 3 is 2, 2 times 4 would be 8, and then here 20 minus 12 would also be 8. This really isn't, these examples aren't really the usefulness of the distributive property, because we could do these examples without the distributive property. So let's go on to show the usefulness of it. Awesome use number 1, mental math. So let's say you want to buy a pack of baseball cards. Actually, you want to buy 7 packs of baseball cards, and each one costs $3.95. So we can use the distributive property to make this a mental math problem. Here's the problem we're trying to work out, and if we could just make it look like this, then we could use mental math. So what we can say is we want something times something. Well, we have that, but 395 isn't a real easy number to multiply with. So what if we would instead multiply by $4 minus 5 cents? Right? $4 minus 5 cents is $3.95. So we want to multiply this $3.95 by 7. And so this problem is the same problem as the one in black there. So using the distributive property, we know that 7 times 4 is 28. And we also know that 7 nickels would be 35 cents. And so $28 minus 35 cents would be $27.65. And let's double check it over here. Let's see if that is in fact the case. So 7 times 5 is 3. 9 times 7 is 63. Plus 3 is 66. And then we have 21 plus 6, which is 27. So although I wrote it out here because I was showing you how to do it, this is actually something you would be doing in your head. 7 times 4 is $28 minus 35 cents, $27.65. So that's awesome use number 1. I use this all the time, and I promise you, if you look for opportunities to do mental math in your head using the distributive property, you will find opportunities to use it as well, and it makes your calculations a lot faster. Okay, so awesome use number 2 is simplifying algebraic expression. That's supposed to have an S there. Expressions. So 3 times x plus 8. Well, you can't add x plus 8, so remember in this beginning example, we were like, well, this doesn't make any sense because we could just do this addition, 5 plus 2, and then multiply by 3. That's easy enough. In this case, we don't know what x is, so we can't do this addition. So we have to use the distributive property in this case. And the distributive property will tell us that 3 has to be multiplied by the x, and also it has to multiply the 8. So the simplified expression here is 3x plus 24. You cannot combine these, and we'll talk about that just a bit later. Moving down to this example, the negative 7 is doing what the 3 is doing up here. It just happens to be on the right side. It doesn't really matter what side it's on. If it's on the right side, it works the same way. We're still going to multiply that negative 7 times both of these numbers. So we need negative 7 times 5b, and then this negative 7 times, oops, sorry, it's a minus, so we're going to have minus 4 times negative 7. And so we're going to get negative 5 times 7 is negative 35, and there's a b there. And then negative 4 times negative 7, or the opposite of negative 28, would be plus 28, however you want to view that. So that's that one. Let's do some more examples. We got this division problem. And it's a fraction, but we can also think of this as a division problem because 7x plus 2 over 5 is the same thing as 7x plus 2 divided by 5. And remember that dividing by something is the same as multiplying by its reciprocal. That's 7x plus 2. All of that is being divided by 5. And so when we divide by 5, that's the same thing as multiplying by the reciprocal. So you can see this problem, we can use the distributive property with it because we can turn it into this. And so using the distributive property, we multiply that 1/5 to both items. And so we have 7x times 1/5 plus 2 times 1/5. So 7x times 1/5 is 7x over 5. And 2, sorry, that should have been a multiplication. And 2 times 1/5 is 2 over 5. And we're done. So this is equal to the original fraction we had there. Alright, let's move on. This is an interesting use of the distributive property. What we have here is the opposite of 2y minus 3x. And earlier in the year we talked about how to get the opposite of a number. So for instance, if I have this number 8 and I want the opposite of it, I could multiply it by -1. And -1 times 8 would give me -8. Well, in this case, I have this 2y minus 3x here, and I want to get the opposite of it. Well, as we said down below there, getting the opposite of it is just multiplying it by -1. So instead of having just that minus out there, we can actually make it look like -1 times 2y minus 3x. So the opposite of 2y minus 3x is going to be 2y minus 3x times -1. Now you can see the distributive property is going to be useful here because we're going to multiply that -1 times both items. And so we get -1 times 2y is going to be -2y. Now minus -1 times 3x. So -1 times 3x is -3x, right? So what we actually have here is -2y plus 3x, which makes sense because the opposite of this positive number should be negative, and the opposite of this negative number should be positive. I know these are a lot of examples, and we'll definitely practice these in class tomorrow, but I've got 2 more. Awesome use number 3 for the distributive property is to identify and combine like terms. And I've rewritten the distributive property here to show how it applies. This actually is not the beginning part, it's actually the end part. So if we flip this around and make it look like AB plus AC equals A times B plus C, this will make more sense. So remember, A, B, and C can be anything. It can be any numbers. So in this case, if we say that A is taking the place of 8 here, and the B is taking the place of the x squared. So what we have here is this A, oops, sorry, I messed that up. The A is the x squared, right? So what we have is two numbers being multiplied together. So 8 and x squared. It makes more sense if you understand the commutative property. Let me move this down. Remember, the commutative property says that we can have these in any order. So technically, what we're going to be looking at is this, and it still works on this side. So we have this 8x squared. So here's the 8, and then the A is the x squared, plus 2x squared. So 2 is the C, and notice the A is still x squared here. So the A is what they have in common. They both have x squared. So we have x squared out here, and then the 8 and the 2 for the B and the C, right? And so what we can see is we have x squared times 10, which is 10x squared. And so what we've done here is we've identified these as like terms because they're both being multiplied by this same thing, x squared. So we know that when two numbers are both being multiplied by the same thing, so B and C are both being multiplied by A, that A can be taken out and multiplied later, and then the C and the B can be added first. So we're just adding the C and the B, the 8 and the 2, to get 10, and then we're multiplying by that x squared. Okay? Again, we'll do some examples of this in class. Finally, we have this problem here. So we got to figure out what the like terms are, and we need to combine any like terms. So I'm going to get rid of this. So what I've done is I've changed the color of all these terms. So we still have a 5x and a minus 3 and a negative 3x and a plus 6y and a plus 4. Using the associative and commutative properties, we can move these around in whatever order we want. So I'm just going to move these around a little bit. So we have a 5x and a minus 3x. Those are going to go together. We have a 6y, which doesn't really have anything to go with it. And then we have a 4 and a minus 3. Okay. Now we know that these are like terms here because the 5 and the 3 are both being multiplied by x. So instead of doing that now, we can multiply by the x after we do 5 minus 3. So we can have 5 minus 3 times x. The 6y is all by itself, so let's just keep that all by itself. And then this 4 minus 3, well, we know what that is. 4 minus 3 is 1. So 5 minus 3 is 2, and so we can simplify this by saying 2x plus 6y plus 1. And that is all for tonight's video.